Hello everyone. Today I am going to solve the problem 4 of homework series 6, which is question 6 from the book. So before solving, let's go through the question and let's see what's the question's demand. So question say a hydrogen atom can ionize in the gas phase and it's given from H with a reaction equilibrium constant K, it goes to H plus electron, and we need to calculate the equilibrium constant K at a temperature T, that is 5000 Kelvin, and some extra information given that we will need later. But before going to solve, let's see exactly we need to calculate for K or something else. When you calculate for K, at that point you need Q. So the Q is directly proportional to volume. But in this question, there is no information about volume. But when you calculate Kp, we need Q naught. And Q naught is basically equal to Q over V. So this volume term gets eliminated. So in this question, since there is no information about volume, we can blindly say we need to calculate Kp. So we will say we will calculate Kp for this question. So I just wrote the formula K for Kp from the book. So formula for Kp says Kp equal to Kt to the power B plus C minus A. It's because B plus C because our equation A is hydrogen, B is hydrogen ion, C is electron, and e to the power minus of delta over Kt, that's the bond energy, with the partition function, which is basically Q naught. And Q naught is further broken down. It's broken down into Q translational, Q rotational, Q vibrational, and Q electronic for each. Okay, so we got information that there is no rotational or vibrational partition function. That means it's 1, or we can ignore these things. We can ignore these things or consider is 1. But there is spin partition function and there is no information about electronic partition function. So let's see what is this spin partition function exactly means. So when you say there is Q electronic from book, so there from like table 11.2 and this equation, you see Q electronic given as something G naught, G1, G2 with some e to the power energy level. So this Q electronic actually arises due to a spin of electron, because each electron have some degeneracy or some energy level and they have some spin in that particular energy level. That's why this electronic function arises. So let's say hydrogen atom have two things, 1s, 2s, and 2p. It goes on, and hydrogen atom can, the electron of a hydrogen atom can stay on 1s or excited to 2s or something like that, and that's why the spin partition function or electronic partition function arises. So whatever it's given as spin partition function is basically equal to electronic partition function, so we need not to worry about it. Okay, so we will see that Q, basically the Q spin for electron is equal to Q electronic partition function for electron, or Q H plus for electron is equal to electronic partition function is equal to Q H plus spin. So these two we can easily equate. Okay, now what will be our electronic partition function hydrogen atom, because there are numerous values given in table 11.2. So given our Kt, we can calculate our Kt, Boltzman constant into temperature. I have just written down over here 5000 into something, the value of K. I got this as 0.408 kilo electron volt. When our Kt is less than 10.2, according to table 11.2, the partition function, the electronic partition function QE would be 2, which is roughly equal to G naught, because this G naught value is 2, and we can ignore all these things. We will assume this tends to 0 if our Kt is less than 10.2 kilo electron volt. And in this case, for this question, our Kt is 0.408, so our electronic partition function will be G naught, or which is roughly equal to 2. So okay, now what will our equation will happen? So our Kp would be equal to Kt. These terms already got 1, so I'll just write Q naught T of, this is translational hydrogen, Q naught T of electron divided by Q naught T of hydrogen into, this is Q electronic, so Q electronic is Q spin of hydrogen into Q spin of electron divided by Q electronic partition function of H. Okay, all these things are done. Okay, now just substitute the values from this equation. We know this thing is 2, we got it. This is already given 2 and this is 1, so this whole thing got cancelled out and makes it to 1. So this whole thing is already 1, we need not to worry about it. Okay, now I just did some simple mathematical manipulation to find Boltzman constant in the unit of atmosphere. This is just because when we are calculating this thing called Kp, so Kp will always come in terms of atmosphere or Pascal or something like a pressure unit. It's not like unitless like normal K. So we need to, that's why like we need the K somewhere in terms of atmosphere. So okay, so normal K value is this 1.38 into 10 to the power minus 23 joule per Kelvin. So joule can be written in Newton meters, Newton into meter, and if you want to write it in Pascal, so Newton per meter square is Pascal, so just multiply divided by meter square. This is Pascal meter cube per Kelvin, and 1 Pascal is 9.869 into 10 to the power minus 6 atmosphere. So I just multiplied this value and I got the K is basically equal to 1.361 in 10 to the power minus 28 atmosphere meter cube over Kelvin. So that is my value of K. So again, going to this, I will calculate this thing first because this is a very big term. So Q translational for hydrogen into electron divided by hydrogen would be 2 pi. Just I have substituted the formula. There is no V term since this is Q naught. And in this case, we'll just assume a mass of a hydrogen ion is nearly equal to mass of a hydrogen. Just a electron mass is negligible. We'll just assume it's gone. We'll just cancel out this term and we'll left off with 2 pi mass of electron kT over h square to the power 3 over 2. Okay, so all these things are done. Now my Kp will be Kt to the power 1 plus 2 minus 1, which is basically 1, and these things come up from here, and e to the power minus delta d over Kt, and we already know that for electronic partition function this is 2 into 1 over 2, or we can say this is 1, so no worries about that. So I'll just calculate each one term and match the dimensions or match the units. So this is 2 pi me Kt over s square, 2 pi, this is mass of the electron, this is our Boltzmann constant, this is my temperature, and this is the value of the Planck's constant. This whole things, after cancelling all the terms, all the units, this comes as kg into second square per joule, which joule is basically this, kg into meter square into second square. If you just cancel out and calculate with a calculator, you will get this. So this value is equal to this. Okay, now we have this thing e to the power minus delta d over kt. So delta d is given in the question, so it's already there. We don't need to go to the table, just mark the units. It's kilocalorie mole inverse. So when you see a mole inverse, instead of k you need r, because k we don't consider mole, but in r we consider per mole. So that's why instead of k we need it in r. So e to the power minus delta d over kt. So I'll just, instead of k, I'll consider r. Delta d is minus of delta d is minus 300 kilocalorie mole, and this is 5000 is my temperature. R in terms kilocalorie mole inverse Kelvin inverse is this. So this is kilocalorie mole inverse Kelvin inverse. So just multiply all these things, you will get this 2.54 into 10 to the power minus 14. So now minus k, my kp will be kt. So I already told we need k in terms of atmosphere somewhere, and that is where we need. Here it is k. This is my Boltzmann constant, this is t, and all these terms that I calculated this formula I just substituted over here. So these terms are get cancelled out. This is meter cube inverse, and once you multiply you will get your kp as this 1.4747 10 to the power minus 11 atmosphere. You can either write it as an atmosphere or Pascal. It depends on your choice if you want to keep in SI units or the normal units. Okay, so the only thing that's new here apart from question 4, that there is no information about volume, that you need to assume that it is Kp instead of K. The second thing is Qs, that is spin partition function, sometimes is equal to the electronic partition function. That's the only new thing in this question. Okay, thank you everyone for your time. Let me know if you have any doubts.